are doing lesson 5.3, solving systems of linear equations by elimination. Now, I want to do a little bit of review before we get into the new lesson. First of all, we have been doing systems of linear equations for a couple days now. So, how many equations are in the problem when we have a system of linear equations? All right, very good. When we solve a system of linear equations, what have we been finding as our final answer? Ordered pair, but what does that ordered pair represent? Point of intersection, or the point of intersection, is what that ordered pair actually represents. Now, so far we've learned two methods for finding that point of intersection, or finding the solution to the system. What was the first method that we learned? Graphing. We used Desmos, we graphed the two lines, and we found the point of intersection. What was the second method that you learned? Substitution. Today you are going to learn the third and final method, which is elimination. Now, to me, if you can understand elimination, and elimination is a little bit more difficult to understand right off the top, but once you get it, elimination is actually what I prefer over substitution because it works a little bit faster. There's not as much work involved in elimination, all right? But you've got to stay with me. The essential question for today says, how can you use elimination to solve a system of linear equations? So here are the 3 steps. Now, there's only 3 steps, which makes it sound pretty simple, all right? But let's look at it. Number 1 says get your x terms, your y terms, your equal signs, and your constants lined up vertically. So essentially, here's what you're going to have to do. You're going to have to make sure that both equations are in standard form. Anybody remember standard form? No?
ax plus by.
Good. Ax plus by equals c. So if each equation is written in standard form, then you can make sure vertically that the x's, the y's, and the constants are all lined up. Now, number 2, step 2 is where the bulk of the work is going to fall. It says choose which variable you'd like to eliminate. So you get a choice. Do you want to eliminate x or do you want to eliminate y? There's really not a wrong answer. However, there is a better choice. So I'm going to teach you as we solve these today how to find the best variable to eliminate. But I do want you to understand, if you decide in your mind, I'm going to eliminate x every single time, that's not going to be wrong. You can do that. Okay? So you're going to choose which variable you'd like to eliminate, then multiply each equation by the number that will make the 2 terms opposites of each other. Now again, you want to eliminate. Let's say you want to eliminate your x term, and one of your x terms is a negative 2x. What is the opposite of negative 2x? Positive 2x. So the only way you're going to be able to eliminate the x term is if one of them is a negative 2 and one of them is a positive 2. So that's going to entail you multiplying the equation, and we'll get to all of that. Once you have solved for whichever variable you kept, step 3, you plug the value of the variable you solved for into the original equation, either original equation, and that's what we did with substitution. So step 3 is not new for you. Once you solve for one of the variables, you're going to plug it back in to either of the original equations. Now, let's look at example 1. How can you use elimination to solve the system of linear equations? Now, again, you're going to have to pay attention to the directions because the directions are going to tell you which method you have to use. The only time you get to choose is if it says solve using the method of your choice. But if it's specific in the directions, you're going to have to use that method. So we have to use elimination today. Now, I want you to look at letter A. First things first, are both of these written in standard form?
Yes.
Yes. Now look at them vertically. Are the x terms lined up, the y terms, and the constant terms all lined up vertically? Yes. So step number 1 is done for us. Step number 2. Now we are supposed to choose a variable to eliminate. And like I said, you can choose either one you want. But let me teach you how to find the best choice. Are either of these variables already set up to where you can eliminate one of them?
Yes.
Yes. Which one is already complete opposites of each other? The x. So why would you choose to eliminate y when they've already set you up to eliminate x? So that's the first thing I'd look for. Are either of the variables already ready to be eliminated? And when they are, we cross them out and we move on. What's 2y plus 4y? 6y. And it equals, what's 7 plus 5? 12. This is a simple one-step equation. How do we solve for y? Divide both sides by 6. So y equals 2. Now, we circle, we don't box. What are we going to do with the fact that y equals 2? Plug it in. Does it matter which of the original equations we use? No, so I'm just going to bring the first one down, and I'm going to go ahead when I write it down and plug in the 2 in place of the y. Okay? So, we obviously have to do what first? Multiply. So we have 3x plus, what's 2 times 2? 4 equals 7. Now go ahead and solve this and listen while you do that. Don't forget, don't call me after midnight. If you are still struggling with the order and how to solve these equations, all right? We don't have the distributive property here. We don't have to combine any like terms. We don't have to move any variables. So we are already at the after. What does the A in after stand for? Adding or subtracting. So what are we moving with addition or subtraction? We're going to subtract the 4. So we're going to subtract 4 from both sides, and 3x is going to equal 3. And then how do we finish solving this? Divide both sides by 3. So what does x equal? 1. All right, and again, we circle, we don't box, because our final answer has to be a what? An ordered pair. And what is the ordered pair going to be? 1, 2. Now don't forget parentheses. Some of you were leaving the parentheses out of your flipped classroom last week. 2 numbers with a comma between them is not an ordered pair. They have to be inside the parentheses. And if you are still struggling, make yourself a little note. The x term is first, or the x coordinate is first, and the y coordinate is second. All right, now let's move right on to letter B. Again, are both equations in standard form? That's our first question.
Yes.
Are the x's, y's, and constants all lined up vertically?
Yes.
Good. So let's move on to step number 2. Now, we're supposed to choose the variable that we want to eliminate. Again, we look, are either of these variables ready to be eliminated? No. So here's the next thing I'm doing, the next thing I'm looking for in order to make the better choice. Okay? Either one works, but one of them is better than the other. The next thing I'm going to look for is one of the terms positive and one of them negative. So when I look at my terms, is one term negative and one term positive? Yes or no? Yes. Okay. So I'm going to choose that variable to eliminate, because when I go to multiply in a minute, at least I don't have to multiply by a negative number, right? Because they're already opposite signs. So you are correct. Y is that variable. Okay, because we have a negative 3y and we have a positive y. Now, what's understood to be in front of that positive y? 1. So here's where it gets tricky. We've got the opposite signs, which is awesome, but we do not have the same coefficient. We've got a coefficient of 3 and a coefficient of 1. So now we have to start finding common multiples. Because when I multiply one of these equations, or both, okay, I need to end up with a common multiple. I need the exact same coefficient, but with different signs. So look at 1 and 3. Now let's review multiples. Okay, I need you to go all the way back to 3rd grade when you learned your times tables. All right, what is 3 times 1?
3.
What is 3 times 2?
6.
What is 3 times 3?
9.
Good, so guess what the multiples of 3 are? 3, 6, 9, 12, 15, and so on and so forth, okay? So we've got a 1 and we've got a 3. We need the common multiple of 1 and 3. What would it be? 3, right? Because I can change 1 to 3. 1 times what will give me 3? 3. So guess what I'm going to multiply the second equation by? A 3. Now the question is, do I have to do anything to the first equation, or does it already have the common multiple? It already has the common multiple. It's already got the 3 that we need. So the first equation does not have to change. So let's just bring it down. X minus 3y equals 24. Now here's the key to multiplying these equations. When I have to multiply an equation, I have to multiply every single term. Now most people don't struggle with multiplying the 3 by the 3x and the y. They forget to multiply it by the answer. So draw the arrows in your notes. You do not have to draw arrows in your homework, your quizzes, your tests, but draw them in your notes. So when you go back to look, you remember, oh yeah, I have to multiply by every single term. All right, so let's do it together. What is 3 times 3x? 9x. All right, what is 3 times 1y? Positive 3y. And it equals, what's 3 times 12? 36. Now can I eliminate the y?
Yes.
Yes, because now they are opposites of each other. So I cross out the y's and I work the rest of the problem. What's x plus 9x? Good. There's an understood 1 right there. So that's 10x equals 24 plus 36, 60. And how do I solve for x? Divide both sides by 10. So x equals 6. Does it matter which equation I plug it into? No. So I'm going to plug it into, let's say, the first one. So I'm going to go ahead, 6 minus 3y equals 24. All right, what would I do first? Good, I got to move that 6, and I'm going to subtract it. So negative 3y equals 18. And how do I finish this? Divide both sides by negative 3. So y equals negative 6. Remember, circle it, don't box it, because what is my final answer? 6, negative 6. Very good. Now, checking is always an option on these problems. I'm not going to make you check, but for those of you that really like to make sure that you have the right answers, let's talk about how we would check our answers. What equation would we plug our answer back into? Now think about what you learned last week. It's only a solution if it makes how many of the equations true? Both of them. So you would take your answer and you would have to plug it into both of your equations. If both of them come out to be true, then you know you have the right answer. So again, I'm not going to make you check, but for those of you that want to check and make sure you have right answers, that is how you would do it. So we looked at letter C and we talked about the fact that everything was set up correctly. We talked about the fact that neither of the variables were ready to be eliminated. Neither of the variables had 1 plus and 1 minus. Okay, so we talked about looking then for a variable that had at least a coefficient of 1. And we decided that both the x and the y had a term where the coefficient was a 1. So we chose to eliminate x, which means we needed a common multiple of what? 4. You have a 1 and you have a 4. So the common multiple of 1 and 4 is 4. So that meant which equation had to be multiplied? The first one. All right. The second equation already had the coefficient of 4. It already had the common multiple of 4. So we had to go and we had to multiply the first equation by 4. But we had to be careful. How many of you picked up on this? If we multiply by just 4, the two are not going to be opposites of each other. So instead of multiplying by a positive 4, you needed to multiply by what? Very good. And I think a lot of you got that. All right. So we multiply the entire equation by negative 4. And let's go ahead and bring down the equation that doesn't change. The second one, 4x plus y equals 13. There were no changes that had to be made to it, so we just bring it down. Then we multiply. What'd you get when you multiply negative 4 times x? Negative 4x. Then negative 4 times positive 4y. Negative 16y. And then you had negative 4 times 22, which was what? Negative 88. So 4 was ready and could be eliminated. What did you get when you did 1y minus 16y? Negative 15y. And it equals 13 minus 88. What did that give us? Someone new. We're letting the same person answer, but everybody needs to be participating. Negative what?
Negative 75.
Negative 75. Awesome. So, Timothy, go ahead and keep going. How did you finish solving for y?
I divided 15 from the left to the...
All right, you multiply, are you divided by positive 15?
Negative 15.
Negative 15. We divide both sides by negative 15, and so y equaled what? 5. Very good. All right, we circle it, we don't box. Joshua, which equation should we plug 5 back into? The first one. Okay, so we have x plus 4 times 5 equals 22. So what'd you do first?
Oh, my bad. I was confused because I did.
All right, well, what do you do first? I multiply 4 times 5 and I get 20. And that equals 22. And then how do I solve for x? Anyone? Good. I subtract 20 from both sides, and so that makes x equal 2. So that makes my final answer what? 2, 5. The ordered pair 2, 5. And again, you can check it if you wanted to. Plug it into both equations and make sure it makes both of them true. Now, let's look at letter D. And if it's hard for you to see on the screen, that is a letter D right there. Are the equations set up correctly? That's the first thing we check for. Yes, they're both in standard form. The x's, the y's, and the constants are all lined up vertically. So, let's start talking through. Are either of these variables ready to be eliminated? No. Is there a variable that has one positive and one negative? Yes. Which one has a positive term and a negative term? The y does. So we are going to eliminate the y. Again, could you eliminate the x? Yes, absolutely. But the better choice is y because the signs are already different. Caitlin, what's the common multiple of 4 and 5? 20. So the first equation is going to have to be multiplied by what number? Now be careful, okay? And I'm actually glad you said that. Not 20. If I multiply by 20, 4 times 20 is 80. Okay? Remember, we need the common multiple of 20. So 4 times what will give us that 20? 4 times 5. So the first equation needs to be multiplied by 5. Now, 5 is here, so 5 times what will give us 20? 4. So the second equation needs to be multiplied by 4. Now, can we keep them both positive? Yes, that's the beauty of choosing a variable where the signs are already different. We get to multiply by positive numbers only. So let's work through these. Jakari, multiply everything by 5 in the first equation. What do you get? 15x plus 20y equals 30. Very good. Trayon, what about multiplying the second equation through by 4? What do you get?
8x minus 20y equals,
all right, somebody help him. What's 4 times negative 19?
Negative 76.
Negative 76. Very good. So 4 times 2x is 8x, 4 times negative 5y is negative 20y, and 4 times negative 19 is negative 76. Can we eliminate the y now? Yes. So what's 15x plus 8x? 23x. And it equals what's 30 minus 76? Negative 46. And how do we finish solving for x? Divide both sides by 23. So what does x equal? Careful. Negative 2. Negative 46 divided by positive 23 is negative 2. Where, Desiree, would you like to plug that? The first one. All right. So we have 3 times negative 2 plus 4y equals 6. Desiree, what do we do first? Multiply. What's 3 times negative 2? Plus 4y equals 6. What do you do next, Desiree? Good. We got to add 6 to both sides. So 4y equals 12. And how do we finish this off? Divide both sides by 4. So what does y equal? 3. And that makes our final answer what? Negative 2, 3. Let's take all that and let's go into our word problem. It says, write and solve a system of equations using elimination. Now guys, if we are writing a system, how many equations are we going to be writing?
2.
We're going to be writing 2. Okay, so keep that in mind. When you're asked to write a system, you have to write 2 equations. Now, let's read the problem through before we mark anything. It says, a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Now, typically at this point, I've already circled the 7 and the 5, and I've already underlined the large and the small. However, we're talking about 2 locations. So the problems are actually going to come once the word problem starts talking about location A. Now you'll also notice the question says, what is the cost of each type of van? So our final answer this time is not going to be written as an ordered pair because we're not going to be graphing anything. Okay, so let's read. Location A receives 5 large vans and 2 small vans for a total, there's that awesome math word that reminds me of what operation? Addition. A total cost of $235,000. So when we're talking about the large vans and the small vans, we're talking about the cost of each. So what do you think this first equation is going to look like? We have, well, first of all, what variables make the most sense for us to use?
X and Y.
We're not graphing though. So really we don't have to use X and Y.
A and B.
We're talking about large and small, so why not
A and
L and S? Large and small. Okay? So 5 large vans. Keep in mind, we are talking about 5 individual vans, and the L is going to represent the cost of that van, right? Because it says the total cost is $235,000. So what do you think we're going to do with the 5 and the L? We're going to multiply the 5 and the L. So let's go ahead and write 5L. Because remember, that's 5 individual vans, and we're going to find L, which is the cost of just one of them. So we've got to multiply the 5 and the L. All right, what about the 2 small vans? What's that going to look like? 2 and S. Again, 2 individual vans. The S is going to be the cost of one of them. So we're going to multiply. What are we going to do with the 5L and the 2S? Add them. Remember, total cost. So when I take the 5 large vans plus the 2 small vans, it's going to be a total of $235,000. Now with that in mind, look at location B. Location B receives 2 large vans and 3 small vans for a total, there again is total, cost of $160,000. So write that equation. What does that equation look like? Good job. 2L plus 3S equals $160,000. Now, these are our 2 equations. So we've got to solve. All right, let's go through and choose the variable to eliminate. Are either of them exact opposites?
No.
Do either of them have at least one positive term and one negative term? Do either of them have a coefficient of 1? So does it really matter which one we choose to eliminate? One's not better than the other. All right, so Jeremiah, do you want to eliminate the L or the S? He wants to eliminate the L. All right, so let's look at the L. We have a coefficient of 5 and a coefficient of 2. What is the common multiple of 5 and 2? 10. So the first equation is going to be multiplied by what? 2. Good, because 5 times 2 will give me the 10 that I need. And 2 times what gives me 10? 2 times 5 will give me 10. Now, can they both stay positive? No, because this time my signs are the same, so one of them is going to have to be negative. Doesn't matter which one? No. So which one do we want to make negative? Let's make the 5. I heard 5. Okay, so we multiply the first equation through by a positive 2, and what do we get? 10L plus 4S equals 235,000 times 2. Now be really careful with your calculators. What's 235,000 times 2? 470,000. All right, let's multiply the second equation through by negative 5. So be careful. Negative 5 times 2L. Negative 10L. Negative 5 times 3S. Negative 15S. And it equals negative 5 times 160,000, which equals what? Negative 800,000. Can we eliminate the L's? Yes. So 4S minus 15S leaves us with what? Negative 11S, and that equals, now be careful, 470,000 minus 800,000 gives me how much? Negative 330,000. And how would I finish solving this for S? Divide both sides by negative 11. So S equals 30,000. Now notice, we're talking about money, and this is a word problem. So don't forget, I'm going to just put a dollar sign. And I'm going to box this in, because remember what we said? We don't need an ordered pair, because they want us to find the cost of each type of van. So we just found the price of the small vans. They're $30,000 a piece. Now, what are we going to do with that information? All right, and let's just plug it back into the first one. So 5L plus 2 times $30,000 is going to equal $235,000. So what are we going to do first? Multiply. So we're going to multiply 2 times 30,000, and what does that give us? 60,000. It equals 235,000. Joshua, what are we going to do next?
Subtract 60,000.
Okay, we're going to subtract 60,000 from both sides. So we know we have 5L equals, now be careful, 235,000 minus 60,000 equals how much? 175,000. And how would we finish this one? Divide both sides by 5. So the cost of a large van is how much? 175,000 divided by 5 is $35,000. And again, don't forget the dollar sign because it is a word problem. And that is lesson 5.3.